Alrighty, so moving right on with our graphs. Another graph that we like to have is a stem plot. You might have heard of this as a stem and leaf plot. So what a stem plot shows is it shows each data value separated into two parts. We have a stem, which is all but the final digit, and a leaf, which is the final digit. So the leaf has one digit and the stem can have multiple digits. The stems are ordered from lowest to highest and arrange them in a vertical column. The leaves are arranged in increasing order out from the appropriate stems. What you need to do, let me get the right pen. You need to include any missing stems. I'm going to show you what I mean by that in a minute. If you skip values, if your data skips values, you are going to have to put that value in as a stem, but then that stem won't have a leaf. Okay, so how to make our stem and leaf plots, our stem plots. So we're going to make our stems, separate each observation into a stem consisting all but the final digit. So our stems are going to consist of all but the final digit. The leaf is the final digit. Write stems in a vertical column from smallest at the top. Draw a vertical line at the right of the column. So you need a vertical line at the right of this column. Do not skip any stems. I cannot stress that enough. If you don't have any value for that stem, it just doesn't have a leaf. Show all stems, even if they're not listed in your data. Add your leaves. Each leaf goes to the right of the stem. Order your leaves. Arrange the leaves in increasing order. Add a key, super important. You will lose points on the AP exam test if you do not add a key. And it will identify your variable and it will explain what the stem and leaves represent. I know it's kind of weird to take in all at once, but it looks like this. Here's an example. So here are the data on resting pulse rates, beats per minute of 19 middle school students. And then they give us our beats per minute. So here's my key. It says 8/2 is a student whose resting pulse rate is 82 beats per minute. So my stems are on the left side of the vertical lines. Here are my stems, and here are my leaves. So 6/8 means 68 beats per minute, 68 beats per minute, 68 beats per minute, 69, 70, 71, 71, 74, 76, 76, 78. And then if we jump down, 104. Notice nobody has beats at 110. No one has beats at 110, and this last kid has 120 beats per minute. This is what I mean by include all stems, because you've got a 6, a 7, 8, 9, 10, 11, and 12. Nobody has 110 beats per minute or 111 or whatnot. Okay? So don't forget your keys, list them all out. And then what's kind of cool is you can see the distribution right here. So we can see this is right skewed because we have more smaller data than bigger data. So the big data here on the right skews my data. So many athletes and their parents worry about the risk of concussions when playing sports. A football coach plans to obtain specially made helmets for his players that are designed to reduce the chance of getting a concussion. Here are the measurements of head circumferences in inches for the 30 players on the team. So coach got a tape measure, said, player 1, come over here. And his head was 23.0 inches. Player 2, 22.2 inches. Player 3, 21.7 inches. He measured all the heads and wrote them down. Now he wants to organize the data so he can help draw a conclusion. So let's make a stem plot of this data. So the first thing he did is he said, all right, I've got my leaves on this side, and we've got 20 inches, 21 inches, 22 inches, 23 inches, 24 inches, 25 inches. And then these are all the decimals on the right. And I know that because of the key. 23 vertical line 5 is a player with a head circumference of 23.5 inches. So when you see 23.5, that's 23.5. Remember, there's only one leaf. So this is 20.8, 20.8, 21.0, 21.5, 21.6, 21.7, 21.9. So that's my stem and leaf plot. Stems, again, leaf. And there is only one leaf per stem. Describe the shape of the distribution. Are there any outliers? Notice it doesn't want me to describe the entire distribution, just the shape. The shape is my skew and peaks. So we're saying the distribution of head circumference for the 30 players, because there's my context. All answers must be in context. It's roughly symmetric with a single peak on the 22-inch stem. There are no obvious outliers. So when I look at this, how do I know it's roughly symmetric? Because here's my shape. So, if you were to look at it vertically, it would have been something like that. Okay, there is no obvious skew. Is it exactly symmetric? No, it's not exactly symmetric. That's why we use the word roughly symmetric. We described the single peak on the 22-inch stem. They included outliers, so let's also include our outliers in shape. Because, like I said, these two guys who wrote the book are heavily involved in the AP community, so they know what they're talking about. All right, and always, 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 I cannot stress this enough, all written answers must include context, and the context is the 30 players on the team. And what are we measuring? The head circumference. So make sure all of your answers include context. Now, sometimes I'll give you two different stem plots. When we can compare two different data sets by using back-to-back stem plots. Both sets of data are share the same stems, and the leaves come from our data sets. So my stem, let me get the right pen here. So the stem is in the middle. And then I have my after exercise leaf and my my resting leaf. Here's my key again. 8 vertical line 2, 8, 2 right here. 8, 2 is a student whose pulse rate is 82 beats per minute. Okay, so we are comparing pulse rate. So this is a back-to-back stem plot of 19 middle school students' resting pulse rates and their pulse rates after 5 minutes of running. So if we look at this, what are the two data sets? Well, we have, so my data sets are resting pulse rate and pulse rate after running 5 minutes. For 19 middle school students. I'm going to abbreviate here. Boom. State the median pulse rate from each set. So in resting, I am going to have, and then I am going to have one after exercise. So median is the middle number. So my numbers are 68, 68, 68, 69, 70, 71, 71, 74, 76, 76, 78. So if we have 19 students, I'm going to cut that in half. And that gives me 9.5. So the 10th, I need 9 items on each side. Another way to do this is to take 19 plus 1, divide that by 2, so that would be 10. The 10th item, 9.5, it tells me that I need 9 on each side of the median. Or you can do 19 plus 1, number of data plus 1 gets 10. The 10th item is my median. So when I look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is the resting median. Because if you count, you're going to have 9 on each side. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So for the resting, the pulse rate is 76 beats per minute. And after running, we've got 98 beats per minute. Alrighty. So to find the median, it's the data, it's the actual data piece or the space that cuts the data in half. Median can be a space. And if it's a space, remember it's the average of the two values on either side. Okay? For instance, let's do a for instance. Let's say my median would have been right there. So I would do 100 plus 104, and I would divide that by 2. That would be my median. All right? Alrighty, statisticians, on assignment 1.2, let's knock out 7 through 11. Moving right along.